Hey guys, this is the last skill of Unit 10. This is 10.5, and in this lesson we're going to be kind of working backwards and solving for some unknowns. So in this lesson, we are going to be given the area, which is different from what we did in all the other ones, where our goal was to find the area. So this time we're given the area. Our task is to solve for a missing base, a missing height, etc. And to do that, we're going to use the formulas that we have been working with all unit, and then we're going to use algebra to work kind of backwards to solve for x, for that missing side, missing base, etc. All right, so let's dive into an example. First example, we're given a parallelogram, and we are given that the area is 98 inches squared. It looks like we're given some information, but not all the information in this case. So step one is to write down the area formula for the shape that you have. So this is a parallelogram. And the area for a parallelogram, the one we've been using, is just base times height. Okay, so now it says we'll fill in what we know. Well, we know that the area was 98 square inches, so we're going to fill that in for big A. And I'm just going to use the numbers. We can go back to units later. Okay, how about base? Let's look at our diagram. Do we have the base? Yeah, we do. We have that whole length there, and it's 14. Okay, but do we have the height? No, we don't, not exactly. Right now, we know that the height is just X inches. So we're just gonna plug that in. Okay, well now we're actually down to a pretty simple algebraic formula. 98 equals 14 times X. All we have to do is get rid of times 14. To do that, we're gonna divide both sides by 14. On this side, it can go away. And we can grab a calculator, or maybe we know this one in our head. 98 divided by 14 is 7. Okay, so our height, and this is how I would like you to write your answer, height equals 7 inches. Okay, the nice thing about these two is you can always check your work. You can go back and grab a calculator, just type in 14 times 7, base times height, and make sure that you are ending up with 98, which we do. So we can move on to the next one. All right, example 2, take some time to jot this picture in your notes. We're going to assume that this is an isosceles trapezoid. I probably should have marked that right away. So let's go ahead and mark that. So we are working with a trapezoid. And the area for a trapezoid formula, remember, was you want to find basically the median of your trapezoid. So you want to do, oops, not an X. We want to do base 1 plus base 2, divide that in half, and then multiply by your height. Okay, so what we have to do now is go ahead and plug in the things we know. So we know the total area is 84. So let's put that in. We know base 1. We know this bottom base is 18. Okay, we don't really know base 2. That's where our x is located. So we'll just leave that as an x for now. Over 2 times height. We do know our height. Our height is 6. Okay, so now the question is, how do we solve this? This one is algebraically a little bit more difficult. There's multiple ways to do it. For me, I think the easiest thing to do is to get rid of the times 6. So to get rid of the times 6, I would just divide everything by 6. So grab a calculator, and 84 divided by 6, if you don't know that one, is 14. So those guys are gone, and it's getting a little bit simpler. 14 equals 18 plus x over 2. Now what? Well, now my x is being divided by 2, so to undo that, I would probably multiply both sides by 2 to get rid of those. So now we have 28 equals 18 plus x. There we go, and now we're to a place where it's not so difficult to solve. Now to get that x by itself, let's just subtract 18 from both sides, and we end up with 10 equals x. So remember, that was our base 2 that we were looking for, so base 2 is going to be equal to 10 meters. Okay, and I am going to take the time on this one to just check it really quick. So I'm going to pretend that I had all of these things. So if I were finding the area originally, I would have done 18 plus 10 divided by 2 times 6. Well, 18 and 10 is 28, and 28 divided by 2 is 14, and 14 times 6 is 84. Okay, and that is what we were supposed to have. So it probably is worth your time on these to just plug your answer back in, check it, make sure that it all works out. All right, and then one last one. This one is a tad bit trickier because it's one of our composite figures. So we are trying to figure out what that kind of unknown height is when we're working with both a rectangle and a triangle. Okay, so let's start with what we were looking for. So we have area equals, we had a rectangle, which is base times height, plus a triangle, which is base times height divided by 2. And now I think we can go ahead and substitute the things that we know in. So we know the total area, okay? Base of our rectangle, let's start there. So our rectangle has a base of 12. We don't want to use the 15 because the 15 is talking about the length of the whole entire figure. Okay, so our rectangle is just 12 by x. So 12 times x plus our triangle. So we need this little piece here. So that's where our 15 comes into play. That whole length all the way down was 15, but we've already used up 12 on the rectangle. So that means we have 3 kilometers left. Okay, and then our height is still x. So our triangle is going to be 3 times x over 2. All right, so now the question is, how do we solve that? That looks like a lot, and it kind of is a lot. The hardest part there is that triangle that's added on. So again, what I would do is I would probably get rid of that divide by 2 first. The tricky thing is everything has to be divided by or multiplied by 2. So multiply by 2, multiply by 2 over here. So let's just go left to right. So 2 times 54 is 108. And then this 2 needs to be distributed over here. So it's not 12 times x anymore. It's 24 times x. And then here we can just cancel our 2's. So plus 3x. And once we do that, it's so much simpler. Now we just have 108 equals 24x plus 3x, which is 27x. And then we're able to just divide both sides by 27. And again, there's multiple ways to do that. If you didn't like doing it that way, I'm sure you can come up with something else that would work. But we do end up with 4 equals x. So the height in both of our figures here is 4 kilometers. All right, I think that's about as tricky as they get on these ones, algebraically at least. So let me know if you have any questions with that, and I can certainly help you through those. Go ahead and practice 10.5.